I welcome you all for the video lecture on linear regression. Linear regression, it is an supervised machine learning technique which predicts the continuous values based on the relationship established between the input and output. Here it assumes that the input changes, the output also changes in a linear way, and the relationship between the input and output is represented by using a straight line. For example, nowadays the gold rate is increasing in such a way, so we are making a prediction on how much the gold rate will be in some future days. So we are having in 2000 the gold rate is this much, and for example for 2000 year, and the gold rate is 1 gram per gold rate is somewhere around 4,000. In 2001, it was increased to 5,000. 2002, it was increased to 6,000. So, like that, you are making a prediction on how much the gold rate will be at 2030. So, how much it will be. So, it is predicting on a continuous value. So, based on the previous predictions, previous values, we are making the future prediction. So we know that if you are fitting any straight line, the equation for that is y is equal to mx plus c, where y is an dependent variable that depends on the x, and m is the slope and c is the intercept. In relating with the linear regression, y it is the predicted output, x it is the data given, and m is the range or the linear function in which the x and y are related to, and c is the error. So let us have an look on linear regression with the numerical problem. Here we are having some data as x 1 2 3 4 5. These are the inputs. The x y it is the output. This is for x is equal to 1, y is 2. That means in 2001 1 gram gold is 2. 2002 1 gram gold is 4. So in that manner, here for x for 1, y is value is 2, 2, 4, 3, 5, x4, y4, x5, y6. So we need to predict the value for 6. For x is equal to 6, how much will be the y? So for that we are having a linear regression formula. So y is equal to mx plus c. It is a straight line equation. So for m, so these values to be found. So n represents the number of values. Here 1, 2, 3, 4 and 5. So n represents 5. Summation of x into y. So x into y. 1 into 2 plus 2 into 4 plus 3 into 5 plus 4 into 4 plus 5 into 6 plus summed up values into n value 5. Then minus summation of x1 1 plus 2 plus 3 plus 4 plus 5, and y 2 plus 4 plus 5 plus 4 plus 6. So like that, and n divided by n into x square, 1 square 2 square, like that, and here all those values summed up and add together and square together. For c, summation of y minus m into this m value into a summation of x divided by n. Then we are computing the values, and we have found it as m is equal to 1 and intercept c is equal to 1.2 based on the previous formulas, and we have finally found the linear regression value y is equal to x plus 1.2. So we are going to predict for value for the 6. So 6 plus 1.2 is just 7.2. So for x is equal to 6, your output will be 7.2. So this was actually checked using the MATLAB code. Here the input we have given and the predicted output y is also given. It was fit into this linear prediction model x and y. For the new entry 6 it need to predict. So that was given to the predict model, and finally the output from the MATLAB code it is like this. So here 1 and 2, so it was mapped 1 x1 and y2. For 2 and 4, so x2 and y4, likewise 5 and 6, x5 and y6. So we are need to predict the 6 x is equal to 6. We from the numerical problem it was found that some 7.2. So here for x is equal to 6 it has found nearly equal to 6.5, 6.6 like that. So there are some errors, so we need to identify the errors and make that model to predict into a better way. So for that we have some error identification methods like matrices like root mean square and absolute mean square, all those error predictions to be given to your model, and to find their original 7.2. For x is equal to 7.2, this model needs to be updated. So review questions on that, try to answer the questions. Thank you.